On this worksheet, we're going to practice calculating oxidation numbers. And I'm going to start by just giving you some refreshers on oxidation numbers. Oxygen atoms are typically having an oxidation number of -2. Hydrogens typically have an oxidation number of +1. For monatomic, so one atom, that means one atom, monatomic ions that typically exist in monatomic form, the charge of that ion is going to be its oxidation number. And then also the sum of all the oxidation numbers always has to equal the overall charge of whatever we're looking at, whether it's a polyatomic ion, molecule, whatever. Some of these are going to be simple, some of these might be a little bit tricky. There is no conventional way to notate the oxidation number in a formula, so we're just kind of going to draw a lot of arrows and squeeze things in. For the first one, we're looking at OH minus. This one's relatively easy. Oxygen is almost always a -2. Hydrogen is almost always a +1. If we add up these oxidation numbers, -2 for oxygen plus the +1 for hydrogen, that equals a total of -1, which is the charge on this compound. So that one's pretty straightforward. For our next one, SO2, oxygen is a -2. We do have 2 oxygen atoms in this particular compound, so together they add up to a total of -4. We don't know what the sulfur is. Sulfur is not one that has a predictable oxidation number, but we do know that whatever the oxidation number is of sulfur, it plus a -4 has to equal an overall charge of 0 because this is a neutral molecule. So just using some deductive reasoning there, we know that the charge, oxidation number on the sulfur has to be a +4 so that it adds up to 0. Down here for our next one, this one, things are getting a little bit trickier. We have an oxygen atom. We know that oxygens are always -2, and there are 7 oxygen atoms in this compound. So that's a total of -14 for all of those oxygen atoms. We've got these chromiums over here. We don't know what their oxidation number is, but we do know whatever it is, so whatever the chromium is, plus the -14 for the oxygen atoms, that has to add up to an overall -2. That's the charge on the molecule overall, or the compound overall. So with this clever math logic over here, we can determine that the chromiums all together need to have an oxidation number of +12. +12 -14 is going to add up to a -2. So all of the chromiums together, there are 2 of them, they all need to add up to a +12. That means that each chromium is going to be a +6. Here's our next example. Things are getting even trickier. We have oxygen atoms. Each one is a -2, and there are 4 oxygen atoms, so that is a total of -8 for all those oxygens. We have these sodium ions, and remember that for something that normally exists as a monatomic ion, like Na+, its oxidation number is its charge, +1. So for this sodium ion, the oxidation number is +1, and there are 2 sodium ions, which means overall they have a combined oxidation number of +2. So we've got all of our sodiums, that's a combined oxidation number of +2. We've got those 2 carbon atoms, we don't know what their oxidation number is because it doesn't normally form an ion, and then we have those 4 oxygen ions all together, they're going to be a -8, and all of this is going to add up to a 0 because this is a neutral molecule. So we're going to do some clever math here again, and we're going to see that the number that's going to make sense to go in this spot is going to be a +6. +2 +6 -8 will add up to 0. So this tells us that all of the carbon atoms together are going to add up, their oxidation number is going to add up to a +6. We have 2 carbon atoms in this molecule, and that means that each one has an oxidation number of +3. This next one is actually easier than the last one we did. We've got 3 oxygen atoms. Did that in a different order. Oxygen is always a -2, and we have 3 oxygen atoms, which is an overall -6. Our chromiums, we know all together have to add up to +6, because +6 and -6 will add up to 0. We have 2 chromium atoms in this molecule. So that means that each one of the chromium atoms has to have an oxidation number of +3. And then down here, last but not least, we have one that looks super tricky and intimidating. This one's got a lot of polyatomic ions in it, and those polyatomic ions are actually going to really help us out a lot in terms of determining the oxidation number. So one of the things that we can do, remember that the charge, the sum of all the oxidation numbers has to add up to the charge. So one thing we can do is sort of treat each one of these polyatomic ions as its own individual entity. We have NH4 plus, that's the polyatomic ion ammonium. We know that hydrogens are going to be +1 each, and we have 4 of them. That adds up to a total of +4. Whatever our nitrogen is, the nitrogen plus the +4 has to add up, whatever nitrogen is, plus +4 has to add up to the total of +1, the overall charge. So that tells us that our nitrogens are all going to be a -3. So we've got that part figured out. Now we can do the same thing for the sulfate polyatomic ion, that is SO4 2-. We know that oxygen is -2, and we have 4 oxygen atoms, so that's a total of -8. We know that whatever our sulfur is plus a -8 has to add up to a -2. So we've got some number here, plus -8 equals -2. That tells us that our sulfur here needs to be a +6. So we have everything figured out except for the cerium in the middle. We know our nitrogen, it's -3, our hydrogen is +1, our sulfur is a +6, and our oxygen is a -2. How are we going to figure out this guy? One way that we could figure it out is obviously by adding up all of these oxidation numbers all together, and then the cerium has to have an oxidation number so that everything totals out to be a 0. An easier way that we could do this is that we could recognize the NH4 plus entity all by itself has an overall sum of -3 plus 4, or +1. So we've got an overall, let me not point at the nitrogen, overall, all of this right here is a +1. -3 plus 4 equals +1, and we have 2 of those ammonium ions right there. So altogether, our NH4 plus ions have an overall +2 oxidation number. That would be if we added up 2 nitrogens and 8 hydrogens, we would get +2. And then let's do the same thing for the SO4. So overall, the SO4 has a -2 charge, or oxidation number. It's a +6 minus 8, that's a -2. And we have 3 of them, which gives us an overall -6. So whatever this guy is, it needs to be +2 plus whatever this number is, -6 has to add up to a 0. So this guy has to be a +4.